Today we will be talking about perspective in the world and paying special attention to our first theoretical concept, which is perspectival measurement. So we measure all the time. If you think about really simple things like measuring temperature, the amount of calories consumed, walking steps taken, time spent at work, we're always making indirect measurements. But we're also in measurement sometimes. So I don't know if you knew this, but Facebook actually had an unhappiness measure at a certain point. There were two groups of people. One group got really positive, happy status updates and news feeds. The other one got not so happy ones. And the whole purpose of the study was to basically see if looking at unhappy things makes you unhappy. Clearly it does, and the study confirmed this. But this is interesting because it's an example of hidden measures. Also, the idea of big data. This is something that is consistent with the paranoia behind measurement. There are all these data sets that are around that are potential measures just waiting to be analyzed. But we can also take a look at measurements that determine policy. Specifically, the kind of research that fascinates me is environmental research. So I did my dissertation on turtles, temperature-dependent sex determination in reptiles. And when I looked at turtles and when I looked at the kind of decisions we have to make about turtles, there is a problem that arises. I refer to this as the measurement problem of turtle mechanics. Depending on if we measure turtles in the lab or in the field, we get completely different measures of developmental phenomena. This is very unusual. Anything from the determined sex of the turtle to the immune function of the turtle to something as simple as the flip-over response. Now the next question is, if we have an interaction between this, the different ways that we can measure turtles in different sorts of setups, as well as the environment. Climate change is a big thing. What kind of prediction can we make about turtle populations in the future? What's going to happen to them in the future? And how can we make policies that are in accordance with those measures and the interaction with climate change? The punchline is measurement is a tough thing. And understanding how measurement works is important to making the right decisions about measurement. So that's why we have to have a measurement theory. So a robust theory of measurement, if we're taking a look at measurements, we can just ask a simple question. Isn't measurement just about looking itself? Isn't it just about discovering or revealing properties that things have? So if you're taking a look at things and you have the right vantage point, then you're doing the right sort of measurement. It seems like a clear-cut solution. Or maybe measurement is about a specific type of interaction between things. Maybe measurement is more complex than we once thought. So the outline for this discussion is as follows. In these modules, I will be outlining the discussion and then going through the steps. Number one, I'm going to give you two necessary conditions for measurement. Necessary conditions, remember, are conditions without which you cannot have something. So if these conditions aren't satisfied, you don't get measurement theory. Remarks about the measurement tradition, and I'm going to call this the representational theory of measurement tradition. This is a tradition that's been around forever. I mean, it's been around since philosophy of science started, as we'll talk about later in this course, but it's also been around in an assumed form for a long time. So for people that are very interested in the history of philosophy, ever since we had the external world tradition, representation is something that we've really battled. How can we get beyond the veil of perception? How can we access the world that is independent of the limitations of our perceptual capacities or our mind? Then we're going to take a look at von Frausten's insight. I call this the perspectival view of measurement. The necessary conditions for measurement. So there are two conditions. Number one, physical interaction. When you measure the world, you are interacting in some way. Even if you're observing the world, there is still some sort of interaction that is going on. And meaningful information gathering process. You can put this in a very simple diagram. You have a thermometer, you have a sample of boiling point, there's a physical interaction, you stick the thermometer in the sample, and some sort of information gets processed. The quantity, whatever that is, average kinetic energy or whatever you're looking at within your sample, gets processed and transformed into a value on your instrument. So the representational lineage is very complex, and the accounts that it gives are very abstract accounts. The representational lineage focuses on systematic assignment of quantities to objects in the world. You can think about this as the relationship between the abstract and the concrete. For example, the abstract values on the thermometer and a concrete sample of boiling water. So the representational theory of measurement, like I said, should actually be called representational theories of measurement, and this is just a tiny list of philosophers of science who have addressed this. And what's amazing about this is this theory has one very large problem, which is, why do we have to take the standard of numerical assignment for all of measurement? Is numerical description necessary and or sufficient for measurement? When you think about measuring, even for example, something like a qualitative measurement in psychology, is there numerical description? Does there have to be? It seems like this is a very strict standard that perhaps is really good for things like physics, but when you're talking about biological measurement and measurement in psychology, perhaps it's not so good. So Bas van Fraassen, who is actually at San Francisco State University, formerly at Princeton, he has really re-envisioned a lot of concepts for us in philosophy of science. We're going to talk about him throughout the whole semester. But right now it's very important to notice what his contribution is to measurement theory. Now the reason why we're starting with this is because it really takes into account our basic interaction with the world. When we measure the world, we get some sort of information. When we measure the world, we interact with the world. And for von Fraassen, the relationship is very simple. We can drop the numerical standard, and we can re-envision measurement completely. So von Fraassen's view of measurement is the perspectival view of measurement, and what I'm going to do is break it down in terms of a few elements. The first one is measurement as being perspectival, measurement as representational, and I'm going to give you all a model of measurement. This is for people who are a little bit more visual when it comes to this. I'm going to give you a model of measurement that distinguishes appearances and phenomena. If you have a hard time with the technical aspects of this lecture, don't worry too much. What's very important for me is that you understand the relationship that's actually going on, that you understand the distinction between appearances and phenomena and how appearances and phenomena interact. This is a very fundamental concept in philosophy, the distinction between how things appear and how they actually are. So we're just transforming this into the scientific context. So first, measurement is perspectival. I think this is a really cool point about our interaction with the world. When we interact with the world, what we're doing is generating a perspective. And perspectives tell us what things look like. So you're standing at a vantage point. Imagine, for example, that you are looking at something from a specific point. You're somewhere in the room, and you move around. You are shifting your vantage point. That vantage point is going to show you information about what that thing looks like and not what it is like. So, really simple example. You all know Davis, California. If you've ever walked around Davis, California, this is what it looks like. You're walking around close to the Coho, and you can take a different vantage point. You're in a helicopter. Different vantage point, satellite. Different vantage point, which we currently do not have, orthogonal to our galaxy. This is something that perhaps we will at a certain point be able to access, but it's an imagined vantage point. All of these vantage points tell us what things look like. So, just to summarize, measurement tells us what things look like. Picture a road, von Fraassen says. So imagine that there's a road and there are two cars that are going to travel side by side on this road, exact same acceleration and velocity. Now picture a painter as a measurer. So von Fraassen says, imagine that someone is on the side of the road on the left-hand side and the two cars start moving, parallel, same acceleration and velocity. This is what the car motion is going to look like from the vantage point of the painter. Now what's interesting is, from the point of view of the painter, you have two different perceived distances. The car on the left is traveling a shorter perceived distance than the car on the right. And for this reason, the painter and his perspective has the measurement content that the car on the right is traveling faster. So you see how this works? Because it has traveled a farther perceived distance, not an actual distance, a perceived distance, it travels faster from the painter's point of view. So the reality is that the cars travel at the same speed, but the perspective is the car on the right travels faster. So the content of the painter's measure, according to von Frosten, gives us what the motions look like, not what they are like. And from the painter's perspective, like I said, the car on the right is traveling faster. So measurement as representation. The important thing to notice about representation is that when we represent things, we get a limited view of those things. We represent things to aspects and degrees. Now, aspects are certain parts or properties, elements, which are selected. For example, if you are measuring the hormonal profile of an organism, you will measure specific hormones, for example, thyroid hormones. In this case, you are getting a limited subset of the total hormonal processes. You can also think about this as going to the doctor and getting a physical. You are getting a physical on certain aspects of your physiology. The second aspect, degrees. So things are often emphasized, idealized, exaggerated. If you think about, for people who are really interested in game theory, a game theoretic measurement setup. And what's amazing about these is, if you do a game theoretic measurement setup, you assume, or you idealize, that all of the agents within that measurement setup have an equal rationality. And this is something that is, in actuality, inaccurate. So sometimes we idealize to make measurements easier for us. Appearances and phenomena. So we can simply diagram von Frosten's view of perspectival measurements by making a distinction between appearances, which are the contents of measurement outcomes, and these tell us what things look like from a measurement setup, and phenomena, which are objects, events, and processes. These are real things in the world. These are independent of measurement. They exist independent of human beings and our interaction with the world. Really simple diagram for this. This is what it looks like. If you notice that when we measure, what we're doing is representing. And when we represent, we get an appearance. This appearance is limited. It is from a certain vantage point. It tells us things to aspects and degrees.